Python. Created in 1991 by Guido van Rossum, Python had one job: make code readable. No curly braces, no semicolons, no sacrificing a goat to compile your program. You write logic almost like English, and it just works. Because of that clarity, Python quickly became the go-to language for beginners, educators, and professionals who wanted to get things done fast. Today, it's one of the most popular languages on the planet. From automating small tasks to powering billion-dollar applications, Python is everywhere. What really makes it powerful is its ecosystem. Python has a library for almost anything: NumPy and Pandas for data analysis, TensorFlow and PyTorch for machine learning, Flask and Django for web development, and countless smaller packages that handle every niche you can imagine. Companies such as Netflix, Spotify, and NASA rely on it daily. Netflix uses Python to manage recommendations and video streaming, while NASA uses it in their equipment control systems and simulations. Python's versatility is unmatched. You can use the same language to analyze satellite data, build a web service, and write an automation script that renames your files, all before lunch. And because it's open source, the community constantly expands it. Thousands of developers contribute to new tools and libraries every year, which is why Python continues to evolve faster than almost any other language. Of course, Python has a dirty secret. It's slow, like really slow. C++ developers look at Python code the way Formula 1 drivers look at golf carts. But here's why nobody cares. Python gets you from idea to working product faster than any other language. A task that takes 100 lines in Java can be done in 10 lines of Python. It's like comparing building a house with Lego versus carving each brick by hand. More importantly, Python scales with the average user. You can start with basic scripting, then move into full-stack development or AI without ever switching languages. It's accessible to newcomers, but deep enough for experts. C++. C++ is the language that can do absolutely anything and will absolutely let you destroy everything. It's the programming equivalent of handing someone a chainsaw, a flamethrower, and a nuclear reactor, saying, "Good luck," then walking away. You have the ability to decide how every byte of memory is used, and the ability to optimize down to the nanosecond. You also have the ability to accidentally corrupt your entire program because you forgot a semicolon in line 847. Two developers can write the same program in C++ in completely different ways, both be correct, and both be impossible to read. By the mid-1980s, software was getting massive. Programs weren't a few pages of code anymore. They were entire novels. And writing all of that in plain C was starting to feel like performing brain surgery with a screwdriver. Born in 1985 as C with classes, C++ took everything fast about C and turned it from chaos to organized chaos. C++ introduced object-oriented programming, allowing developers to bundle data and functions together into objects. It might sound obvious now, but back then it was revolutionary. Suddenly, you could design software like a system of small, organized components instead of one giant mess of logic. By the 1990s, C++ was everywhere. Microsoft Windows, Photoshop, Autodesk Maya, and Mac OS all used it. It powered desktop software, operating systems, and the first generation of 3D games. And it still hasn't gone anywhere. The Unreal Engine, which runs games like Fortnite, PUBG, and Final Fantasy VII Remake, is built on C++. So are major parts of Google Chrome, Amazon's back-end systems, and Facebook's core infrastructure. Basically, if something is fast, reliable, and important, there's a good chance it's quietly powered by C++. It's also a favorite in finance and telecommunications, where performance isn't just nice to have, it's non-negotiable. When a trading system can lose millions in a millisecond, fast enough means written in C++. But with great power comes great confusion. C++ gives you a massive toolbox. Classes, templates, inheritance, operator overloading. It's not that C++ is hard. It's that it gives you so many options you end up debating yourself at 3 a.m. about which one is technically better. Quick question. Which of these languages frustrates you the most? Drop it in the comments. I'm genuinely curious. Alright, let's talk about Java, the language that refuses to die. Java. Java is the programming language equivalent of a middle manager who wears a tie to Zoom calls and has been running Fortune 500 companies for 30 years, and he's not going anywhere. Born in 1995, Java promised the impossible. Write once, run anywhere, and for the most part, it delivered. In C, you print "Hello World" in one line. In Python, maybe two. In Java, you're declaring a public class, defining a static void main method, importing system.out, and basically writing a legal document just to say hello. But that structure has a purpose. When you're managing a codebase with 50 developers across 10 time zones, Java's verbosity becomes clarity. Everyone writes code the same way. No surprises, no creative solutions that break everything. That's why banks love it, airlines love it, governments love it, because Java code from 2006 still runs today and will probably outlive us all. Instead of compiling straight to machine code like C, Java runs inside the Java Virtual Machine, or JVM, a sort of universal translator that lets the same program work on Windows, Mac OS, Linux, or even your smart fridge. It might make your laptop sound like it's taking off, but it'll run and keep running. Boring, reliable, and absolutely not going anywhere. That's Java. JavaScript. If programming languages were people, JavaScript would be the unpredictable friend who somehow gets everything done, even though no one understands how. It was created in just 10 days in 1995 to make websites interactive. Today, it powers 98% of the web, handles front-end interactivity, and thanks to Node.js, even runs servers. Even this video you're watching is most likely using JavaScript somewhere behind the scenes. Here's the catch. JavaScript makes no sense. Developers call it a forgiving language. What they really mean is that it silently lets you destroy everything without throwing an error. But despite its quirks, or maybe because of them, JavaScript became unstoppable. Every major website, every online tool, every front-end framework is built on it. React, Vue, Angular, Next.js, you name it. The real magic? It runs natively in every browser. Performance-wise, JavaScript isn't the fastest, but the modern V8 engine built by Google turned it from toy language into a legitimate powerhouse. You can build real-time apps, 3D games, and even back-end APIs entirely in JavaScript now. But remember, it's a wild ride. 1 minute everything works, the next you're staring at undefined is not a function and questioning your life choices. Still, for anything web-related, JavaScript is king. Love it or hate it, you can't escape it. In fact, the video player you're watching right now, the comment section below, the like button you're about to click, all JavaScript. TypeScript. TypeScript is what happens when JavaScript goes to therapy. By the early 2010s, web apps were massive. What started as small scripts to animate buttons had turned into full-scale apps with thousands of files. And JavaScript was letting developers ship bugs to production like it was their job. That's when Microsoft stepped in with TypeScript. It wasn't meant to replace JavaScript, it was meant to fix it. The core idea was simple: add static typing. In plain terms, TypeScript checks your variables, functions, and parameters before the code runs. If you accidentally pass a string where a number should go, TypeScript tells you right away instead of letting your website crash during a live demo. That single feature changed everything. Large-scale JavaScript development suddenly became manageable. You could spot mistakes instantly, document your code automatically, and let your editor auto-complete everything with confidence. TypeScript compiles down to regular JavaScript, which means it runs anywhere JavaScript runs: browsers, servers, mobile apps, and even IoT devices. There's no performance penalty because what ships to the user is still plain JavaScript. The impact was huge. Frameworks like Angular, Next.js, and React all added first-class TypeScript support. Google, Slack, Airbnb, Asana, and Microsoft now use it across their front-end and back-end systems. It's become the default for any serious web project. By 2025, surveys show that over 40% of professional web developers use TypeScript in production. Rust. Created by Mozilla in 2010, Rust had one mission: deliver C++ performance without the C++ disasters. Rust is a systems programming language, which means it works close to the hardware, but with one critical difference: safety comes first. The secret is Rust's borrow checker, a system that enforces memory safety at compile time. It tracks how every piece of data is accessed, ensuring you never use invalid references or create race conditions. Here's the Rust experience. You write code, the compiler says no, you fix it. The compiler says no again, you fix it again. The compiler says no 47 more times. But once it finally compiles, you know it's rock solid. Rust has topped the most loved language survey for 8 straight years. Not because it's easy, but because once you master it, you never want to go back. Rust delivers the speed of C++ with the security of a managed language. Mozilla originally used it to rebuild parts of the Firefox browser, improving both stability and performance. Since then, Amazon, Microsoft, and Dropbox have all adopted Rust for performance-critical components. Even the Linux kernel, which was written almost entirely in C for over 30 years, officially began integrating Rust support in 2022, a massive milestone for software safety. Rust also shines in concurrency, running multiple tasks at once without letting them interfere. Where C++ might allow 2 threads to corrupt the same memory, Rust simply refuses to compile code that unsafe. That makes it ideal for modern workloads, cloud computing, game engines, and blockchain systems where one crash could mean real money lost. The learning curve? Steep. Developers often say Rust is like learning to think differently about programming. Less improvisation, more discipline, but once mastered, it's empowering. You write code that's both fast and trustworthy. Rust has topped the Stack Overflow Most Loved Language Survey for 8 consecutive years, and its community is growing fast. C, the foundation. C isn't just a programming language. It's the godfather programming language, the one every other language either learned from, stole from, or is still paying tribute to. C is the reason your phone works, your car starts, and the Mars rover didn't crash into a rock. Born in the early 1970s at Bell Labs, C was created by Dennis Ritchie to rewrite the Unix operating system, which, up to that point, was written in assembly, basically programming in raw machine instructions. Painful, tedious, and one typo away from frying your system. C changed that. It offered the speed of assembly with the readability of English-like syntax, which was revolutionary. Suddenly, developers could write portable code, programs that worked across different machines without needing to be rewritten from scratch. That one idea? Portability made C unstoppable. By the 1980s, it was everywhere, powering Unix, forming the base of Microsoft Windows, and even influencing Mac OS decades later. If you've ever used Linux, you've used C indirectly. The Linux kernel is almost entirely C. The Python, Ruby, and PHP interpreters? Written in C. Even modern browsers like Chrome and Firefox rely on C for their rendering engines. Why? Because C talks almost directly to the hardware. No virtual machines, no garbage collectors. When you write C, you're practically whispering into your CPU's ear. You decide how memory is used, when it's cleaned, and how every byte moves. That control is exhilarating and dangerous. Forget to free memory? You've created a leak. Right past an array boundary? You've opened the door for hackers. Entire cybersecurity breaches have started with tiny C mistakes, like the Heartbleed bug in 2014, caused by a simple memory handling error in OpenSSL, a C library used by millions of websites. It exposed private keys, passwords, and sensitive data across the internet, all because of one unchecked buffer. But that's the trade-off. Power and precision come with risk. C gives you total control and zero forgiveness. Yet, that's why it endures. C is used anywhere performance matters. Operating systems, databases, embedded systems, game engines, and network drivers. If you're running a router, a smartwatch, or even a Mars rover, there's C code humming beneath the surface. It's not beginner-friendly, and it definitely won't hold your hand. But learn C and you'll see how computers really think. Every modern language, from C++ to Go, Rust, and even Python, owes C a debt. It's not just a foundation. It's the bedrock the digital world was built on. Go. Go, or Golang, is what happens when Google engineers get tired of waiting for their code to compile. Their goal? Build a language that's fast, clean, and doesn't make you want to throw your laptop out a window. It's not flashy. It's not trying to be clever. It just works. Fast, stable, and predictable. Docker, the tool that revolutionized how we deploy software? Written in Go. Kubernetes, the system that orchestrates millions of containers? Also Go. Companies like Google, Uber, Dropbox, and Cloudflare use it for services that need to handle millions of requests per second without falling apart. Syntax-wise, Go is clean and strict. There's one way to do things and the compiler enforces it. That consistency means teams can collaborate without debating code style for 3 meetings straight. It compiles blazingly fast, deploys easily, and the binaries are tiny. No dependency nightmares, no works on my machine drama. Just run it and go. Developers love it because it just gets out of the way. And there you have it, 8 languages that power nearly everything you touch. Now here's the thing, you just learned what languages run your code. But do you know what hardware actually executes it? Because what's the point of writing perfect Python if your CPU is bottlenecking at 100% and you have no idea why? That's exactly what we're covering next. Every computer component explained simply. CPU, GPU, RAM, motherboard, all of it broken down so you actually understand what you're buying. Click the video on screen right now and I'll see you there.